Hello everyone, my name is Rebekah Emery and I'm back again with another math video. In this video, I will talk about Module 5, Chapter 7, Decimals, Real Numbers, and Proportional Reasoning. Let's get started. For our first slide, how do you change decimals to fractions in lowest terms showing denominators with prime factorization? Well, this may sound complicated, but if we follow these simple steps, it will seem quite easy. First, we need to realize that every decimal reads like a fraction. Our first number is 225 thousandths, which is equal to 225 over 1,000. We can easily see that both 225 and 1,000 are divisible by 5. If you remember the divisibility rule that I went over in the last video, you'll catch on. After reducing our fraction to 45 over 200, we can see that both the numerator and the denominator are divisible by 5 once again. So our answer, 9 over 40, is the lowest term for this fraction. Now let's look at 36 thousandths. It is equal to 36 over 10, which are both even numbers divisible by 2. We can divide the numerator and the denominator by 2 and reduce the fraction to 18 over 500. Again, we can reduce this fraction by dividing each part by 2. Now we have 9 over 250, which is the lowest term for this fraction. Next, we will look at showing the denominators using prime factorization. To make this illustration easier to read, the prime numbers that divide into both is purple. If it only divides into the 40 side, it will be red. And if it only divides into 250, it will be blue. After factoring out both numbers, we have 40 equals 2 times 2 times 2 times 5. And for 250, we have 2 times 5 times 5 times 5. Now, in order to present this information correctly, we have 40 equals 2 to the third power times 5 to the first power, and 250 equals 2 to the first power times 5 to the third power. Now, for this one, we're going to use a graph. A question for this one would be like, how can I graph an equation y equals x over 2? Well, let me give you an example. Say, for example, the Emery family on vacation eating out at Subway on a budget. Graphing can intimidate students unless you can show them a scenario that breathes life into the equation. For example, my family is always needing to economize because I have 9 people in my immediate family. You add 2 sister-in-laws, a niece, a nephew, and you have a 13-member family with growth potential. Moving on, a 12-inch sub is less expensive than 2 6-inch subs, yet by purchasing 12-inch subs, everyone gets the same quantity at a lower cost. Let's first look at a T-chart of the X and Y variables. If you have 2 people, you purchase 1 sandwich. 4 people would purchase 2 sandwiches. And of course, if you have an odd number of people, you can order another 12-inch sub and someone will get to enjoy the lagniappe. For those who don't know what that is, that's a South Louisiana term for a little something extra. Now let's look at the graph. You can easily see that the Y variable goes up 1 more sandwich for every 2 people that need to be fed. So in the graph, in the T-chart, you can see that if you have 2 people, then they would just order 1 12-inch sub and then cut that right in half. Or if you have 6 people, they would just order 3 subs and just cut that right in half. Or if you have 10 people like me and my family, you can just order 5 12-inch subs and cut that right in half. And you'll be good to go. Moving on to fractions and percents. Question, how do you find the fraction and the percent of the red shaded portion? Well, when you're looking for a fraction and a percent of a shape, the first thing you must do is to make sure all parts are the same size. Let's begin with a simple example. Here there are two parts of equal size and one part is shaded. Our fraction is 1/2 equals, which is equal to 1 divided by 2, which is 0.5, which then equals 50%, or 50 out of 100. Moving on to our problem, you can see there are 9 squares within a square. 3½ squares are red, but we cannot make a fraction with a numerator of 3½. So notice how we divided all the squares into triangles. Now there are 18 parts for the denominator and with 7 of the parts shaded red. 7 will be the numerator. Every fraction is a division problem. We get 0.3888, which is about 39%. We just rounded up to the nearest 100th place for the percent. Now to find the fraction, the number of shaded portions is the numerator and the number of total portions is the denominator. It is very important to be sure that all portions are equal in size. Now, to find the percentage, remember that every fraction is a division problem, as I said about 3 times already, just to get that in your head. Every fraction is a division problem. Divide the numerator by the denominator. Percent means out of 100. So we get the percentage by moving the decimal point to the right of the 100th place and adding a percent sign. And that's how you find the fraction in percent. Now let's match each shape to the correct percentage of the hexagon. A question for this slide could be, how can I determine approximate percentage of the whole? Well, let's look at these shapes and determine the percentage of each compared to the whole. The whole for this activity will be the hexagon. We will compare the shapes below to the whole to determine which shape is the smallest percentage up through the shape that is the largest percentage of the whole hexagon. So which shape appears to be the smallest and therefore will be the smallest percentage of the whole? Well, let's see. For 16.67% of the hexagon, it looks like the triangle would fit that spot. The second one up at 19.2% looks like it would be the skinny tan rhombus. And then for third spot at 33.3%, looks like the blue rhombus is it. And for the fourth one at 38.5%, it looks like the red square. And finally, at 50%, is the red trapezoid. So looking at what I have in front of me, I can see that the green triangle, which is 16.67%, it looks like I can fit about 6 of those in there. So all I have to do to find the whole, I would just multiply 16.67 times 6 to get 100%. I can also see the blue blue rhombus. It looks like I can fit about 3 of those in there. So to get the whole, I would just multiply 33.3 times 3 to get 100%. And obviously 50%, I could fit another red trapezoid in that hexagon and to get 100%. To solve that, I could either say 50 plus 50 to get 100, or I could say 50 times 2 to get 100, but whichever is easier for you. So for the shapes that do not have an easily divisible percentage or an obviously whole number, that fit into the hole, such as the skinny tan rhombus at 19.2 or the red square at 38.5, we simply look at each shape's relative size compared to the rest of the shapes to determine the percentage. Moving on to common percentage problems. I want to make a smoothie for 3 people. It takes 1 cup of almond milk for each smoothie. What percentage of a quart will be left after I've made the smoothies? Before we solve all that problem, let's look at our variables and what they represent. On the left, we have the B variable, which represents 1 quart of almond milk, which is the equivalent of 4 cups of almond milk, and our A variable, which represents 1 cup of almond milk. Now, to find the percent, our question is, given A and B, what percent of P of B is A? Our answer would be 1 cup is 25% of 1 quart. To find the part, our question is, given a percent P and the whole B, what is A if it is P percent of B? Looking at our information above, it looks like our answer is 1 cup is 1/4 part of a quart. To find the whole, our question is, given a part A that is P percent of the whole B, what is whole B? Look, given our information, our answer clearly is 1 quart is 4 cups, or 100%. To answer my question, what percent of a quart will be left after I've made the smoothies? The answer is 4 cups equals 1 quart. 1 cup times 3 smoothies equal 3 cups. 3 cups is 3/4 part of 1 quart. 3/4 is 75% of 1 quart. So therefore, there will be 25% or 1/4 part or 1 cup of almond milk left. Moving on to mud cake. 3, 2, 1 mud cake. So mud cake is made by creating a mix of 1-to-1 mix of a box of angel food cake mix and a box of your favorite cake mix. To make the mud cake, you use 3 tablespoons of the mix with 2 tablespoons of your preferred liquid. Water, milk, soda, just anything you feel thirsty for. After 1 minute in the microwave, top with 1 tablespoon of your favorite icing, and it's a yummy treat anytime. So a question that I could use for mud cake for you guys would be, how can I make a graph that shows a rate of proportional change? Now, let's look at a table. If I only want 1 mud cake, I only need 3 tablespoons of mix, 2 tablespoons of liquid, and 1 tablespoon of icing. But if I want 2 mud cakes, I have to multiply all the ingredients in the basic recipe by 2. And likewise, for 4 or 8 mud cakes, I would multiply the basic ingredients by 4 or 8 to have the proper amount of ingredients. So now let's look at a graph of this basic information. You can easily see the rate of proportional change when the table of information is transferred to a graph. And that's mud cake, i.e. mud cake is made in a coffee cup of any size you want, really. And that's my video for you guys. I hope you enjoyed it. I had fun making this PowerPoint. Just remember that the best thing you can wear is confidence. See you soon. Bye.